right, class, today we're going to do lesson 3.2 and 3.3, parallel lines and transversals. It may be helpful for you to have some highlighters, colored pens, colored pencils to just distinguish between some special angle pairs. All right, so when we look at this picture, we have interior angles and we have exterior angles. So we have visited with this a little bit, but interior angles are the ones between the transversals, and the exterior angles are the ones that are not between the transversals. Okay, so alternate interior angles, this is about the third time we've covered this, so hopefully it's getting easier and easier about characteristics of alternate interior angles. They are on opposite sides of the transversal, and they are interior. Now, we have not necessarily talked about what if the lines are parallel. So, if two lines are parallel and they are cut by a transversal, then alternate interior angles are what? So, if we look at this picture and we look at line R and line S, and I'm going to tell you that they are parallel for this example, we have alternate interior angles, angle 1 and angle 8. And you have to decide if those two angles are congruent or whether they are supplementary. So if you look, angle 1 and angle 8 are both acute angles, and the alternate interior angles property says if R is parallel to S, then alternate interior angles are congruent. So if we look at our other pair of alternate interior angles, we have angle 5 and we have angle 4. That means angle 5 would be congruent to angle 4. We also have the converse of this theorem, so it goes the opposite direction. The converse of this theorem says if alternate interior angles are congruent, then the lines are going to be parallel. So this goes two ways. So if we use the original theorem basically says if R is parallel to S, then angle 1 is congruent to angle 8. The converse of that theorem, which would be down here, basically says if angle 1 is congruent to angle 8, then line R is parallel to line S. So really it just kind of goes both ways. If you know the lines are parallel, then the special angle pair is congruent. However, if the special angle pair is congruent, then the lines are parallel. All right, it works pretty similarly for most of these. So alternate exterior angles. So characteristics of alternate exterior angles would be that they are exterior, and they are on opposite sides of the transversal. So if we have two parallel lines, so let's look at our picture and say that line R is parallel to line S, then alternate interior angles are going to be congruent. And I'm sorry, we're on alternate exterior angles, so alternate exterior angles will be congruent. So what does that really mean? That means that if we look at alternate exterior angles, so maybe we look at angle 6 and angle 3. So this basically says that if R is parallel to S, then angle 6 is congruent to angle 3. Or you might actually use the other pair of alternate exterior angles, which could be 2 and 7. So we could also say that angle 2 is congruent to angle 7. When we come down here and we talk about the converse says if the alternate exterior angles are congruent, then the lines are parallel. So on the flip side, this goes the other direction. If angle 6 is congruent to angle 3, or angle 2 is congruent to angle 7, then line R is parallel to line S. Okay, So that's the alternate angle. Same side goes another direction. So same side angles, characteristics, they are on the same side of the transversal. And in this case, they're going to be interior. So if we look at my theorem, the theorem says if two parallel lines are cut by a transversal, then same side interior angles are. So if we look at a pair of same side interior angles, angle 5 and angle 8. So if we look at angle 5 is obtuse and angle 8 is acute. So when I look at those visually, there is no way that those can be congruent. However, the theorem says that if two lines are cut by a transversal, two parallel lines are cut by a transversal, then same side interior angles are supplementary. I remember this because same side and supplementary all begin with the same letter, so SSS, same side supplementary. So if we think about that as an example, if line R is parallel to line S, then the measure of angle 5 plus the measure of angle 8 is going to add up to 180 degrees. Now, we could also use the supplementary angles on the other side. So you have angle 1 and we have angle 4 over here. So we could always take the measure of angle 1 and add that to the measure of angle 4, and they two will sum 180 degrees. The converse says the same thing the other direction. So if same side exterior angles or same side interior angles are supplementary, then the lines are parallel. So basically we're going to take the converse of the statement we wrote before. So if the measure of angle 5 plus the measure of angle 8 adds up to 180, then R is parallel to S. And you could also use the other pair of other pair of same side interior angles. So we could also use the measure of angle 4 plus the measure of angle 1 adds up to 180. So either way, it works with both pairs of same side interior angles. All right, we're going to start feeling a little bit redundant because same thing happens for same side exterior. All right, corresponding angles. So they have corresponding locations, different intersections. So corresponding locations. So like top right corner, you can think of it as southwest and southwest, whichever one is the easiest. So if I take a pair of corresponding angles, angle 4 is obtuse, angle 2 is obtuse. So when I look at those, two obtuse angles cannot be supplementary. Therefore, if two parallel lines are cut by a transversal, then corresponding angles are congruent. So if I write that using examples, if R is parallel to S, then angle 2 is congruent to angle 4. And there's also 3 other pairs of corresponding angles in this picture. You could have used any of those 3 pairs. So now we're going to take the converse. If corresponding angles are congruent, then the lines are going to be parallel. So for the converse, we simply switch the hypothesis and switch the conclusion. So if angle 2 is congruent to angle 4, then R is parallel to S. So let's look at this in a table form. I'm going to use a highlighter. You are welcome to just circle the answers on your paper, but a highlighter is a little bit easier in this situation. So angle pairs. I basically remember that SSS, same side supplementary. Otherwise, it's going to be congruent. So alternate interior angles, congruent. Alternate exterior angles are also congruent. However, same side, and that's how I remember supplementary. They all begin with the same letter, so same side supplementary. We learned in a previous unit that vertical angles have nothing to do with parallel lines, but they will occur throughout this unit and they are congruent. Corresponding, if you cut the lines and place the intersections on top of each other, they land right on top of each other, therefore they're going to be congruent. And again, same side also begins with S, so same side exterior angles are supplementary. So truly, if you will use that shortcut SSS, those angles, same side interior, same side exterior, are supplementary, while everything else remains congruent. All right, so let's look at angle or example number 1. So example number 1 says that A is parallel to B. So I look at A and it's parallel to B, so that means I have some special properties. It says find the measure of the missing angles. So first of all, I have to look at what I'm given. I'm given this angle here and this angle here. So those are the two with the expressions that I have to work with. So I have to decide, are they alternate interior, are they alternate exterior, same side angle pairs, are they congruent, or are they supplementary? So when I look at those have the same location at each intersection. So I determined pretty quickly that those are corresponding angles. So we have corresponding angles. And if I recall from the theorems, corresponding angles are congruent, which essentially means that 15x plus 5 is going to equal 12x plus 30. So now I'm going to do some algebra. So we are going to subtract 12x from both sides. So 3x plus 5 equals 30. I'm going to move my 5 over, so subtract 5 from both sides. 3x equals 25. Divide by 3. And you guys can have a moment of panic. One of my favorite F words of math, fractions. So we're going to take this problem and it has a fraction in it, and that is okay. They are numbers too. So if you look at what the instructions to this problem say, it says find the measure of the missing angles. So just because we found x, we are not finished. We really need to find angle y and angle z. So let's substitute x back into one of these expressions. So 15 times 25 over 3 plus 5. And yes, you can work with fractions without a calculator. It's amazing. Okay, so we have 15 in my numerator, 3 in the denominator. That reduces to 5. 5 times 25 is 125. Plus 5 is 130. So now when I look at my pictures, this angle here is 130. This angle here is 130. So from there, I need to determine the measures of y and z. So if I look at angle y is vertical to the 130 degrees, so angle y is going to be 130 degrees. And if I look at angle z plus the 130 degree angle I already know, they are going to be a linear pair, so they are supplementary. So if I have one angle that's 130, then the supplement to that is going to be 50 degrees. The biggest thing in these problems is step 1, you have to determine right here, are these two angles going to be congruent or are they going to be supplementary? So once you get that going, the rest is just algebra and answering the correct question. Okay, so example 2. So it says R is parallel to S, so that's a bonus because I'm able to apply the parallel line theorems. And I look at this special angle pair, so I know this angle here and this angle here, and they are opposite sides of the transversal, so they're alternate and they're interior. So if I have alternate interior angles, they are going to be congruent. So let's take and set 78 equal to 102 minus 2y. So you can hit pause, do your algebra, and come back and check your answer here in a second. All right, welcome back. I'm going to subtract 102 from both sides, so we should get a negative 24 equals a negative 2y. Do not lose your signs, they are important. So when I divide by negative 2, a negative 24 divided by a negative 2, a negative divided by a negative is a positive, and I get 12 equals y. If you look at the instructions for this problem, they ask you to find the value of y, so therefore we are done with problem number 2. Okay, here we go. Example number 3. So determine what values of x will make f parallel to g. So this is the other direction. They want to know, hey, we are not telling you the lines are parallel. Tell us what x could be so that these lines are parallel. And if I look at this special angle pair, these are on opposite sides of the transversal, and they're exterior. So they're alternate exterior angles. So if alternate exterior angles are congruent, then the lines are going to be parallel. So my goal is to find out what value of x will make them congruent, which will make the lines parallel. So this time I'm going to take and I'm going to set these two equal to each other. So if we solve for x, you can hit pause and do this on your own. That way I don't go too fast for you. But I'm going to subtract 12x from both sides. You could do it a different way if you wanted to. Negative 2x plus 5 equals negative 9. Then I'm going to subtract 5 from both sides. Negative 2x equals negative 14. Divide each side by negative 2. And x equals 7. If I want to check that answer, I can plug 7 in for both of these x values. And when I do that, 10 times 7 is 70 plus 5, which is going to give me 75. 12 times 7 is 84. And if I subtract 9, 84 minus 9 is 75. So since both of these answers are 75 degrees, that tells me that my lines are parallel. Now, I'm going to put a disclaimer on this picture. This picture is not drawn to scale, because if this was drawn to scale, those would be acute angles, and by looking at the picture, they're definitely obtuse. So don't always assume that your pictures are drawn to perfect scale. All right, have a great evening, and we will see you in class tomorrow.